everybody. Today we are going to be talking about 5.18, more quadrilaterals and their properties. Don't forget at the end of the lesson to make sure that you do the lesson check and the attendance quiz. Don't forget those things. So we're going to talk about some trapezoids, and we've seen trapezoids when trying to find their areas, but we're going to talk about some of the properties that they have also. So we have talked about how a trapezoid has parallel bases, and that is true for all trapezoids, whether it's isosceles or not isosceles. All trapezoids have parallel bases. In a non-isosceles trapezoid, you have one pair of opposite sides that are parallel, and the consecutive angles between the parallel lines are supplementary. So this is just properties of parallel lines that we've already learned. So if I have two parallel lines and a transversal, then the consecutive interior angles are supplementary. And so that would be true in our trapezoid because it has parallel bases. In an isosceles trapezoid, it still has parallel bases, but its legs, the sides that connect the bases, are congruent, just like in an isosceles triangle. So the non-parallel sides, or the legs, are congruent. Also in an isosceles trapezoid, the diagonals are congruent. The base angles, so the angles that touch the bases, are congruent, and opposite angles are supplementary. So in this picture, these are a pair of base angles because they are touching the same base. They are congruent. And then these are also base angles because they are touching the same base. And we know that the consecutive interior angles are supplementary. So if this arc, this angle, is supplementary to this angle, then this angle is also supplementary to this one, since these two are congruent. I like to think of an isosceles trapezoid as a shape that I could definitely fold. It has a line of symmetry. And I can only fold it one way. I could only fold it in half this way. I would not be able to fold it top to bottom. It wouldn't fold exactly on top of itself. So if you can think about it as folding on top of itself, maybe like a holiday card or a birthday card or something, then you'll be able to see exactly which angles land on which other angles and which ones are congruent. Maybe that'll help. Let's practice using those properties. My first example, I have a trapezoid, and I know it's a trapezoid because the top and the bottom bases are parallel. However, this is not an isosceles trapezoid because this leg and this leg are clearly not congruent. So we have a non-isosceles trapezoid, and we will know that the consecutive angles here are going to be supplementary because they are consecutive interior angles for these parallel lines. So I know that angle M plus 87 equals 180. And the same idea will go here. These two angles are consecutive interior angles, so the measure of angle K plus 51 has to equal 180. And we can solve for each measure. So subtract 87 from both sides, and we get angle M equals 93 degrees. And the measure of angle K, we'll subtract 51 from both sides, and we get 129 degrees. Example 2 is very similar, so go ahead and try that one. Try number 2. Find the measure of angle C and the measure of angle D. Okay, so in this trapezoid, angle A and angle D will be supplementary, so I can say that angle D plus 62 equals 180. Angle B and angle C are supplementary, so angle C plus 31 equals 180. And then I can solve for each angle. So for angle C, you should have 149 degrees, and angle D, 118 degrees. This idea will also work if they are giving us expressions and not just missing values. So in this one, we're going to solve for x. Here, the bases of my trapezoid are here and here, and I know that because those are the parallel sides. So here is my transversal. These angles are same side or consecutive interior angles, so they are supplementary. So I can add them together to get 180. Okay, so we'll combine our like terms, 54 and 6. I'll subtract 60 from both sides, and then divide both sides by 8. So we get x equals 15. It was just asking me for x, so we can stop right there. But if I wanted to check this, I could plug this in and do 8 times 15 plus 6. I get 126. 126 and 54 added together do give me 180, so I know that I solved this correctly. Okay. In number 4, we're going to find the measure of angle R. So first we're going to find x, and then once we know what x is, we'll be able to plug that in to find the actual measure of angle R. So try that now. Look at angle Q and angle R, set up an equation that relates those expressions, and solve for x. Try that now. Okay, so angle Q and angle R are supplementary because we know that consecutive angles in a trapezoid are supplementary, or you could think of it as parallel lines with a transversal. Consecutive interior angles are indeed supplementary. Either way, you're going to add those together, set them equal to 180. Combine your like terms. 12x and 7x is 19x. Positive 3 and a negative 13 gives you negative 10. I added 10 to both sides and then divided by 19. If this was a multiple choice question, 10 would have definitely been an option, but 10 does not answer the question. Because it says find the measure of angle R, I'm going to take that 10 and plug it into the expression for angle R. So 7 times 10 minus 13. So the measure of angle R is indeed 57. So moving on, we are going to be talking about some isosceles trapezoids. And I like these guys because I like to think of them as folding in half. So if I were to think of trapezoid DEFG as folding in half, it would fold right along this line. And I would see that angle D would land on top of angle E, angle G would land on top of angle F, and all of these sides would land on top of each other also. So here, it says that DG is congruent to what? Well, if I were to fold this trapezoid in half, DG would land right here on EF. So DG is congruent to EF. DF is going to be congruent to EG because in an isosceles trapezoid, the diagonals are congruent. Over here in this one, again, you can think about folding it in half. And it says angle T is congruent to what? Well, angle T would land on top of angle U, so they have to be congruent. And angle V would land on top of angle W, so those would have to be congruent. With our trapezoids, we also have a midsegment in a trapezoid. The midsegment in a trapezoid connects the midpoints of the two sides, or the legs. So E is the midpoint of AD, and F is the midpoint of BC. When that happens, what we've done is we've created a third line that is parallel to the bases. So because EF is a midsegment, I can say that AB is parallel to EF, and EF is parallel to DC. And then there is an equation that relates the length of the midsegment to the bases. The length of our midsegment, EF, is going to be half of the length of the bases added together. So the length of AB plus the length of DC. If you don't like this 1/2, you don't like working with fractions or whatever, that's okay. Multiply both sides by 2. If I multiply EF by 2, I have 2EF. And if I multiply this side by 2, it cancels out the half. So if you want to avoid working with the fraction, you're welcome to use this equation instead, and you'll get the exact same answer. Okay, let's look at this one. So in this one, I know that EF is a midsegment, and how do I know that? Well, E is the midpoint of AD, and I know it's the midpoint because I've got two congruent pieces here. And F is the midpoint of BC, and I know that because these pieces are congruent. So now because it's a midsegment, I know that it's parallel to AB and DC, and I know that the length of EF is half of the sum of the bases. And if you don't like that fraction, just go ahead and multiply both sides by 2. It's the same thing. Okay, so let's use this information to find EF. So if AB equals 14, I'm just going to go ahead and put 14 up here, and DC is 26, let's find EF. You don't like working with EF as 2 letters, go ahead and give it a variable. How about X? So to find, in this case, X, the midsegment is half of the bases added together. Or you can set it up the second way. 2x equals 14 plus 26. Both ways work. I'm going to solve this one. 14 plus 26 is 40. Divide both sides by 2, you get 20. So EF equals 20. For the second one, EF is now 22. So I'll make this a 22. DC is 38. Let's find AB. I'm going to call that X again. So we can say that 2 times the midsegment equals the bases added together. And we can solve for X. Subtract 38 from both sides. X equals 6. So our final answer, AB equals 6. Okay, very good. Let's move on. All right, so for this one, we have a midsegment of a trapezoid again, and I know that because it's telling me that Y and Z are midpoints of the legs. So Y is the midpoint of this leg, Z is the midpoint of that leg. And it wants us to find YZ. So we're going to have to use some algebra to solve, and then we'll plug our X in to find the length of YZ. So we know that 2 times our midpoint, or midsegment, 2 times our midsegment is the sum of the bases. And remember that addition's commutative. So if I wrote X plus 14 plus 38 here, we'd be writing the same thing. One thing that I think a lot of students forget to do is distribute to both parts in the parentheses. So just distribute that 2 to both. 10x minus 38 equals 38. Oh, let's combine like terms. I can combine my 38 and my 14. So 38 and 14, give me 52. I'll subtract x from both sides. Add 38 to both sides. And divide both sides by 9. So x equals 10 will help me find yz. So I'll go to yz and I will plug in a 10 for x. 5 times 10 minus 19. 50 minus 19 is 31. So my final answer, yz, is 31. If I wanted to check that, I could also plug it in here, 10 plus 14, and know that SR is 24. I could add 24 and 38 and divide that by 2. I'll get 31. If I don't, then I did something wrong. All right, here's another example. We've got some expressions for each segment here. Wx is x plus 7, uv is 8x minus 3, zy is 6x plus 5, and it tells me that u and v are midpoints of the legs. We're going to find the length of uv. I'd like you to try this one. Set up the equation, solve for x, and plug it in for uv. It's okay if you get it wrong, but I would like you to try this one so that way you have some work to compare when I share my answer with you. All right, so you should have gotten x equals 2. Now when you plug that in, uv was 13. When you set up your equation, you set up 2 times 8x minus 3 equals x plus 7 plus 6 plus 5. And don't forget to combine your like terms. And don't forget to distribute that 2 to both parts inside the parentheses. If you did not get 2 or you did not get 13, please just take a moment to pause and see if you can find your error. If you can't find your error, put a star next to this one so you know to ask for help during office hours. The last slide of this, I included the same little diagram that we had in one of our previous lessons, but I also added the trapezoids for you too. So this could be a good study device, practicing and to remember the properties of each of our quadrilaterals, including our trapezoids, our isosceles trapezoids, and even some midsegments. A trapezoid is not a parallelogram. Parallelogram is today's attendance quiz word. The reason a trapezoid is not a parallelogram is because it has only one side of parallel sides, whereas a parallelogram has two. Make sure you spell parallelogram right. Please spell it right. Okay, if you get it wrong the first time, double check your spelling before entering it again. I hope you guys have a wonderful day. If you have any questions, please don't hesitate to attend office hours and reach out for some help.